I'm here in my hotel room just about to give you your lesson. Hopefully this works. This is very similar to yesterday's lesson with two linear equations, except this is a 3 by 3, three unknowns with three equations. Basically, these equations are planes, and therefore they intersect at once, none, or all in a line, just like last time. So we'll go over all those situations. So the first thing you want to do is eliminate a variable. It doesn't matter which variable. In my case, I'm looking here and it's either the x's or the y's that look really nice. I'm going to go ahead and eliminate the x's by adding row 1 and row 2 together. So sometimes I just say row 1 plus row 2, and here's what I get. So when I add those together, I get y plus 2z equals 5. Now, for the other option, because I've eliminated x, I need to do it again. But because I used row 1 and row 2, I have to use row 3 somehow. I don't care if that's row 1 and row 3, row 2 or row 3, but I have to use row 3. And because row 2 is already negative, I'm going to times that first. So I'm going to say 2 times row 2, and I'm going to add that to row 3. So here's the work for that. Another color really quick. So if I times this really quickly, I get negative 2x plus 6y plus 6z equals 8. When I add that to row 3, I get 3y plus 7z equals 18. Once again, that was 2 times row 2 plus row 3. Now, as we look at this, this looks exactly like what we did last time. It's like a system of equations with linear. So I'm going to use elimination again, and I can eliminate the y or the z's. It does not matter. I'm going to go ahead and eliminate the y's by timesing the top by negative 3, and I get negative 3y minus 6z equals negative 15. When I go ahead and add those, I get z equals 3. So just like yesterday, then I go ahead and then go replace it. I'm going to go replace it right there. So I have y plus 2 times 3 is 6 equals 5. Y equals negative 1. And then I go ahead and replace both z and negative 1 into one of the equations at the very beginning. I'm just going to use number 1. So x minus 2 times negative 1 is plus 2 minus z, which is 3, equals 1. So therefore x minus 1 equals 1. So x equals 2. So my coordinate is 2, negative 1, and 3. I could go back and plug it into any of those equations and it should work. Next equation. Sorry, it's thinking a little bit. Alright, same idea. We're going to look at this one. And if you'll notice, our y's are the easiest to solve for because I could add row 1 and row 2. Let's go ahead and do that. Row 1 and row 2. If you add those together, I get 2x. Notice the y's get rid of each other. Plus 2z equals 14. Now here you want to be very careful with your negatives and your additions because the fact of the matter, when you miss it by a negative, it's going to throw the whole thing off. So just be careful with that. So the other one I'm going to do is row 1 and row 3. Because once again, if I add those two rows together, my y should cancel. And notice I get 4x. The y's cancel. I get negative 2z this time. Oh, this is pretty. And I get 4. When I add these two rows, just like I would do elimination with a 2 by 2 as we did in lesson 10.1, I'll go ahead and add those together, and I get 6x equals 18, and look how nice that is, x equals 3. With that being said, I go ahead and plug it back in. I'm going to plug it in right there. So I get 6 plus 2z equals 14. Subtract it over. 2z equals 8. So z is 4. How nice is that? I have two numbers, so I just got to go plug it back in. Any of them really would work. I'll plug it back into row 1, so that's 3 minus 2y plus 3z. Oops, I know what z is, so I better replace that. We know z to be 4, so I'll go put a 4 there. Equals 1. Now notice, this is 12, so I can just simplify by saying negative 2y plus 15 equals 1. Negative 2y equals negative 14. Y is 7. Once again, knowing all of them, 3, 7, 4. X, Y, Z. Go ahead and plug those in. If you would like to check into any of the three equations, it should work in all three. If it doesn't work in all three, then that means that we did struggle. So we'd have to go try again. Okay, so far we're doing really well. Onward to the next slide. This is just a visual showing that there are many different cases where we have exactly one solution. That's this, where they all meet just one spot. This one is no solution right here. Notice all three planes don't meet. Two planes meet in all cases here, but not all three of the planes meet in one spot. And this one is infinite solutions. Notice it's a line, and so therefore anything on that line would work. Okay, they have different wording here. It says a system with no solution is being inconsistent. A solution with many solutions is dependent. Inconsistent just means that, hey, you're not going to have an x, a y, and a z that equal these values for all these cases. So therefore, once again, a no solution is said to be inconsistent. Many solutions is said to be dependent. Okay, we're going to go ahead and see what we have. We're going to pick one of each. We've already obviously seen a one solution. Let's see what the next one is. So as we see here, it wouldn't be too hard to multiply row 2 by a negative 2, but I think I'm just going to multiply it to get rid of those y's again, because it looks really nice to get rid of those y's. So I'm going to go ahead and multiply row 1 by negative 1. So I'm going to say negative row 1 plus row 2. Here's negative row 1, negative x minus 2y plus 2z equals negative 1. Here is the row 2, so we'll just put it right next to each other just so we can see it. Go ahead and add those two together, and here's what we're going to get. So I get x plus z equals 5. So once again, very similar to last time's homework, a system of equations as a linear, even though it's not x and y, but two variables, it's very similar. So notice I just did row 1 and row 2, so as I said in the first example, that means I have to involve row 3. So I still want to eliminate the y. It doesn't really matter on this one if I use the the first row or the second row. I'm going to go ahead and multiply the first row by negative 2. So negative 2 row 1 plus row 3. Once again, the key thing is I have to use all three rows. And notice I've used row 1 and row 2. Now I'm using row 1 and row 3. I do have to use all three rows, but one of them you're going to have to use twice. So as I multiply that top by -2, here's what I get. I get -2x minus 4y plus 2z, 4z, because I'm multiplying by -2, equals -2. Here's the next one on the very bottom. I have 3x plus 4y minus 3z equals 5. Let's go ahead and go through that really quickly. And so when I add those, I get x gone plus z equals 3. Now, if you'll notice those two, let's just copy these down here really quick. X plus z equals 5. X plus z equals 3. Now look at this. We're going to do the math, but if we look at this really quickly, can x plus z equal 5 and x plus z equal 3? That's no. So right now I kind of know it's a no solution, but I'm going to prove it to you as I go one more step. I'm going to multiply the top row right here by -1. So let's go ahead and times that by -1. I get -x minus z equals -5. X plus z equals 3. And notice when I add those two rows together, I get 0 equals -2. And can 0 ever equal -2? No. So this is a no solution. This is one of those cases that they might intersect at one point for two planes, but all three planes don't meet. So therefore, this is a no solution. Okay. Skipping over. All right, let's see what we got here. Once again, as I'm looking here, the x's don't look too bad to get rid of, nor the y's. I'm going to go with the y's for the fact of the matter that row 1 and row 2 just add straight up. So I'll just do that really quick. Row 1 plus row 2. I'm just going to add those because these y's right here, I'll highlight them. These y's right here are already going to get rid of each other. So when I add these, here we go, we get 3x. The y's cancel out like I just said, plus 9z equals 0. Now, as I said before, row 1 and row 2 have been used, so therefore I have to use row 3. Now, as I look at here, I'm going to use row 1 and row 3 to get rid of the y's because row 1 has a negative on it already. Like I told you guys the other day in class, if I don't have to multiply by a negative, I don't want to. So therefore, I'm just going to go 4 times row 1, and I'm going to add that to row 3. So really quickly, 4 times row 1 would be 4x minus 4y plus 20z, that's a little bit bigger, equals -8. I'm going to go ahead and add that with row 3, and here's what we get. We get 6x, the 4y's cancel, I'm left with 18z equals 0 again. Okay? So this is just exactly like we did last time. 2 by 2, a system of equations of 2 by 2 with elimination. I'm going to go ahead and multiply the top row right here by -2. Here's what I get. I get -6x minus 18z equals 0. When I go ahead and add them, I get 0 equals 0. Because of this, this is infinite solutions. So if you recall from last time's lesson, I'm going to take one of these two equations. Okay, one of these two equations. I'm going to take this one, or I'm going to take this one, and I'm going to solve for a variable. Either of them doesn't really matter. I'm going to go ahead and solve for x because I believe in row 1 here, this guy, that x is easier to solve for. Let's go ahead and do so. So I have 3x. I'm going to subtract that 9z over, equals -9z. So therefore I know x equals -3z. So as I talked to you guys about it this last time, X as being the dependent variable, meaning if I don't know Z, I wouldn't know X, in this case, the way I've solved for it. So I'm going to scroll down a little bit. So therefore, in my answer, here's what I have. I know Z is my independent variable. X is going to be, okay, well that's equal to 3Z. Now, if you chose to solve for Z instead, it'd give us just an answer, but it'd be slightly different. So just be aware of that. So now the goal is, I got to go pick one of those equations and plug in what I know for what I have. Let's go use number 1. So let me rewrite that right here. X, I'm just going to rewrite it and I'll show you what I do. Minus y plus 5z equals -2. All right, now let me show you what we're going to do here. Hopefully you can read my handwriting. Sorry, I'm doing this on the mouse and it gets a little harder. So what we're going to do is, what does x equal? Well, x equals -5z. So therefore, -3z, sorry about that. So I have -3z minus y plus 5z. Now notice if you look here, I only have one equation with 2 unknowns, which is okay because I'm going to figure out what y is so I can put it into the system. So let's go ahead and solve for y. So I'm going to add him over. So he's going to come over here, and this 2 is going to come over here. So I get 2z plus 2, because he came over from the other side, equals y. So therefore I know what y is in terms of z, so therefore I can just substitute it right up in there. Here we go. 2z plus 2. So this is where my infinite solutions comes from, because if I know one value of z, let's give a for instance. If I knew one value of z, let's say z is 5. Okay, I just chose that, that's random. I can plug that 5 up in here, right? And for this variable, let me just highlight it just so you guys know where I'm at. I'm going to plug 5 in there. I'm going to plug 5 in there. So therefore, for the x value, I have -3 times 5, which is -15. I'm going to plug 5 right there. 2 times 5 is 12. 12 plus 2, excuse me, I got to start that again. 2 times 5 is 10. 10 plus 2 is 12. I just went a little bit ahead of myself. So notice, guys, this is a solution to that equation. It should work if you plug it up into the top. But this right here, this is the answer to that. As we're going through that, the reason why it's the answer is because that will give us any solution I plug in for x, hence, excuse me, z. Hence why infinite solutions, because there's an infinite amount of numbers I can plug in. I could plug in pi for all I care. It's still a solution. Okay. With that being said, that is my last example. You guys are going to do 10-2. I'm going to hurry and look that up, and I'll come back to you with this solution. Just give me 1 second. All right, really quickly after looking over it, 7 through 37, every other odd, 39, 41, 43. I just noticed there were some story problems, so I'm going to hurry and cut and paste one of those story problems. So we'll go together just to look. Out of your book, I'm going to pick one of the even ones. How about this number 40? I like this 40 right here. We'll just cut some paste. Give me 30 seconds here. Okay, 30 seconds, guys. Let's just go on. Bring that up just a little bit bigger for you. All right, here we go. So it says, a gas station sells 3 types of gas: regular, performance plus, and premium. So we're going to call that X for regular, Y for premium plus, or performance plus, sorry about that, and Z is for premium. Okay, just so we know our variables. All right, so they sell it for $3 for a gallon of regular, $3.20 for Performance Plus, and $3.30 for Premium. On a particular day, they used 6,500 gallons of gas. Let's stop right there. So that means X plus Y plus Z equaled 6,500. Because they had to use all three gas to get there. They also said that they sold for $20,050. So as that's saying, well, I know it costs $3 for every X. I also know it's $3.20 for every Y. I also know it's $3.30 for every Z for that total of $20,050. Okay. Now our last one, because once again we're doing a system today, and if I have three variables, that means I have to have at least three equations. That's the rule. For however many variables there are, that's how many equations you need. So if I had 5 variables, I need 5 equations. Those are important to know. So the next sentence, though, it says 3 times as many gallons of regular as premium were sold. So that means for every gallon of premium, it's 3 times that to get to the regular. Let's make sure that you understand that. Sometimes people struggle with those. Well, it says 3 times as many gallons of regular as premium. So therefore, I know I have to times the premium by 3 to get what the regular is. For example, think in your head, if I have 6 gallons of premium, how many regular does that mean? Oh, 18. So therefore, this equation works. So really quickly, it's nice because I already have one of my questions in a 2x2, if you see this. Okay, my 2x2 is x minus 3z equals 0. Okay, so what's that nice about is between these two, I'm going to go ahead and eliminate the y just because like down here, the y is already eliminated. So therefore, I'm going to times this top here by negative 320. Okay, here's the work. I get negative 320 x, negative 320 y, negative 320 z. And I'm going to hurry and use my calculator down here. 30 seconds, guys. So I have 320. I got to make him negative. Times by 6,500 is negative 20,800. I'll rewrite that. So that's equal to negative 20,800. When I go ahead and add this to the purple one, to this bottom green one, I get negative 0.20x, positive 0.10z. When I do those two together, I get negative 750. Okay, so let's go ahead and then once again I'm going to eliminate x really quick. So I'm going to times this top one by negative 0.2. Excuse me, positive. Let's just do positive. So I have 0.20x minus 0.6z equals 0. Those cancel out. Negative 0.5z equals negative 750. When I go ahead and divide it, I'm going to hurry and use that calculator one more time again. Where is he at? I have negative 750. Sorry, let's do this different, clear. So I have 750 negative divided by Let's see what I'm dividing by. Negative 0.5 divided by 0.5 negative equals 1500 for z. So z is 1500. So I used 1500 of premium. Now once again, because I know he's 1500, I go plug it right here. So my regular is 4500. Now if you use these two together, that's 6,000 gallons of gas. And notice they use 6,500, so I also know Y is 500. Now if you check all three of those equations, it should come out. Let's go back here one more time for the homework. The homework is 10-2, 7 through 37 every other odd, 39, 41, 43. Thanks guys, I appreciate it. I'm going to be putting this on YouTube. You can check it out. Thank you. Have a good day at school.